Hello guys, welcome back to another video, and today we're playing Universe Sandbox 2, and we're going to be seeing what would happen if we were to place the sun with a planet. Now I know what you're thinking, that's a really bad idea. Planets aren't going to be able to orbit another planet. Well, you'd be wrong, because we're using the largest planet that we've ever discovered. This one right here. Oh crap. Alright, now that we have the largest planet in the center, we just gotta go to here, view, and then we gotta go down to, simulation stuff. I don't know, actually. Oh, wait, no, it's not in view, it's in tools. And the system management, and click auto orbit. And now everything should be orbiting this right here. There we go. Yeah, everything's working out fine for now, but some things that you're going to start to notice is if we go down to here, Earth, you'll already see that the Earth is completely frozen over, as the Earth cannot, oh, yeah, normally it wouldn't be like that. If we go back to view here, you will see that normally it wouldn't be light like that. Like, it's not like that's what it would actually look like, but this is what it looks like for simulation purposes. So we can actually see what's going on. And so now you can see that the entirety of the Earth has been frozen over. You can't see the city lights on the back because everybody died due to the freezing cold and hypothermia. Now, if we look back at Jupiter over here, you can see that all these asteroids have been displaced. They're all everywhere. You see that? That's because, well, Jupiter's gravity. The largest planet has the mass of 9.5 masses of Jupiter. And Jupiter has a mass of, well, one Jupiter, you'd guess that. And if it's 9.5 masses of Jupiter, imagine, since the sun is 1,000 masses of Jupiter around there, and there would be if there was a red dwarf right here that was 100 masses of Jupiter, you could imagine that since this would be 1/10 of the star's mass, it would have a much bigger gravitational influence, causing all of the asteroids in the asteroid belt to get pulled towards Jupiter. As you can see, if we speed up time a bit, you'll start to notice that this asteroid, I bet it's going to go towards Jupiter. This one will. Yeah, this one is. And this one's also going towards, you can see them all going towards Jupiter. Hygeia is probably going to go towards the Jupiter too. Yep, Hygeia just got flung towards Jupiter. Yeah, if we turn on orbits, you can already see that the outer solar system has been messed with a lot. Like, look at Pluto's orbit. It's absolute chaos out here. You can see that's because of Jupiter's much bigger influence. Everything on the outer solar system is going to get bent and wobbled. If we go back to Earth here, you'll start to see, you can look at the temperature, which is negative 246 degrees Fahrenheit, negative 154 degrees Celsius for all my buddies in Europe, or anywhere else in the world other than the United States. And, if we look at, this planet, you'll see that it's also really, really big. Like, if you take Jupiter right here, that's Jupiter, the largest planet in the solar system. And compared to the sun, this is what the sun looks like next to it. It's pretty close in size to the sun. It's a planet, which is pretty crazy. Because this planet isn't very dense, is it? Yeah. Yeah, see, it has a really low density. That's what I thought would happen. because how could something so big have such a small mass for its size? You can already see that orbits are being bent out more around here. It's really not that great for this stuff and stuff. And so if we go back to Earth, oh wait, let's look at Jupiter actually. Oh yeah, another thing that's happening with Jupiter is even more of these asteroids are going to get displaced, and pretty soon what's going to happen is, oh wait, yeah, look at that. Saturn is orbiting Jupiter now. It's pretty crazy. Oh, these asteroids keep getting flung outwards. Let's see if Ceres gets pulled in. Oh, Saturn isn't really orbiting Jupiter anymore. But look at Saturn's orbit. It just got all messed up. Because this completely would... Yeah, let's for simulation purposes, let's delete all the objects that have been flung out. Because they're lagging the sim. But wait, we don't know if some of these objects are going to just come back. Yeah, some of them are not getting ejected. Some of them are coming back, so yeah, let's just leave them for now. Go back to Earth, and we'll see something else is that the temperature has gone down even more. Right now it's negative 192 degrees Celsius, negative 314 degrees Fahrenheit. And all of the water has been... Okay, I don't know. Yeah, like, another thing that would be happening is on the surface, under the ice, some of the water would still survive because of the Earth's core is warm, which would keep some of the water underground alive, but that's it. And the only living things that are still around here probably be far, far under the ice, like deep, deep under the ice. And all that would be left is probably just some bacteria or some sort of tube worm, or I don't know, some sort of mushroom or fungus that lives in the deep sea. Because that's the only thing that could really survive down there. Because photosynthesis would completely stop, so no plant would be able to exist. Anything like that. No way. Another thing is that a lot of the ice that was frozen what I assume happened to the salt is all of the water, and it froze. The salt must have gone somewhere, unless it's trapped in the ice. You know what? Let's look that up. Let's see what happens if... What happens if ice or salt water freezes? Oh yeah, it says, according to the AI overview, it says it forms ice crystals but pushes most of the salt out, creating pockets of super salty dense liquid brine and leaving the ice itself with very little salt, making it nearly fresh. So then, yeah, I guess we got our answer. That means this is what I expected to happen too. So that means that all of the ice, the water, or the salt in the water that got frozen, all that ice, all that salt turned into a thick liquid called brine, full of salt, and went under the ice. And so now, what I assume happened is all the ice under the all the water under the ice is probably extremely salty because all that salt water from the ocean went down after it froze. Pretty cool. So if we look at Venus, Venus is still really warm. And this is because if we look at the composition of Venus, look at the atmospheres of Earth, you can see that there's 91.2 atmospheres of Earth worth of carbon dioxide in the atmosphere. which is causing a greenhouse gas effect. This is when, because before the sun was still here, it still has leftover temperature from that. And that causes Venus to get very, very hot. Because of it traps in all the heat. And also, in Celsius. Yeah. In Celsius, that's 149 degrees Celsius. And also, for all the people who use Fahrenheit, if you're wondering, 100 degrees Celsius is boiling and 0 degrees Celsius is freezing, like freezing water. Now, if we go to Earth again, you can see the big difference here. It's negative 316 degrees Fahrenheit or negative 193 degrees Celsius. But it's like 300 degrees Fahrenheit here and 149 degrees Celsius here on Venus, which is pretty crazy. It's really cool how the way that works. Another thing you'll notice is all these asteroids from the asteroid belt. Like Eunomia, Ceres. Well, Ceres is technically a dwarf planet, but you get the point. All these asteroids have been flung inward due to Jupiter. This is what happens, and then eventually some of these asteroids could crash into Earth and cause even more destruction. Another thing is you can see some of the even already cold planets are just going to keep getting colder, which is pretty crazy. And since there's no good source of heat, all these planets, all the gases on or liquids on all of the planets are eventually just going to freeze solid. Even the gases are going to turn to liquid and freeze solid, meaning Jupiter here. Jupiter is a gas giant, and so are all the other gas giants, but this isn't going to get simulated in game. But what would happen eventually is it would get so cold that all of the ice or all of the gas would turn to liquid, and then that liquid would turn to ice. Pretty crazy. So Jupiter and all the other gas giants would just turn into ice balls realistically. Same thing with this gas giant here, the largest planet ever discovered, would also turn into a big ice ball. Sorry. Another thing is you can see this right here. This asteroid has been captured by Jupiter, and you see this is bound to happen because Jupiter's gravitational pull is much stronger now. Well, it's not stronger, it's just that there's no sun to keep a firm hold of everything. Instead, there's just this weak little gas ball that does not have a firm hold over everything and can't keep everything in place like the sun can. Like, it's kind of like imagine this. The sun is a huge magnet, very, very, very strong. It holds everything in place, nothing moves around because it's just stuck there. The sun pins it to the ground, pins it to the wall. Nothing can move. Nothing can move out of place. Everything has to stay put. Then we get a smaller magnet. You see a smaller magnet, like a fridge magnet or something. This magnet would not have as good of a hold over everything. And so this would cause all these other stronger magnets, that, like the weaker magnets that are strong compared to this magnet here, pretty strong, light. These ones would have much more of a strong pull compared to the hold. It's like trying to hold something, right? You're strong. You can hold it. You can hold it in your hand, and somebody tries to rip it out of your hand, you can keep holding it still. But then, if you're weaker, you can't hold it on as well, so they can rip it out of your hand much easier. It's kind of like what's happening here. Sorry if my lectures are kind of boring, but I feel like I need to explain stuff in case people don't know what I'm talking about. Because it's always, I hate being confused. So, yeah, I just try to explain everything as best as that I can. Yeah, I don't think these guys are coming back. So I'm just gonna go to tools. And then delete all escaping bodies. There you go. Oh, look at Neptune. Neptune's not gonna be able to hold on. Yep, Neptune just got ejected too. But it might come back, like the last time. I thought it got ejected, but it came back. Let's see. Let's see, Neptune. Oh, yeah. Neptune came back. Yeah. Neptune's barely holding on. Because the gravity out here is so much weaker than it is in here. Like here, the largest planet ever discovered has a much firmer pull over everything over here in this area, but out here, everything's so far apart and far away that the gravity of this is hard to come by. So it's not really having a good pull out here. So things go flying. Like you can see, the entire outer solar system has basically been cleared. Besides Jupiter, it's just full of asteroids now. But the inner solar system, yeah, it's full of asteroids, but at least all of the planets in the inner solar system are still in their original spots. Well, I don't know, actually, Mars might have moved a bit, but that's about it. You know? Because everything in here is a much firmer hold. Because everything's so sparse and far apart in the outer solar system, it creates much bigger distances. And gravity drops the farther you go out. Like right here, the gravity would be much, much stronger than, like it's really strong here. But if we go out, it's much weaker out here. Like really, was that, what? Oh, I thought that was Phobos. It's Folius. I was gonna say, Phobos wasn't in the simulation. I don't know why it's here. You can see Ceres, the dwarf planet, is now a moon of Jupiter, but it's probably gonna get ejected from Jupiter's hold again. Same thing with Saturn, how it was before. Oh, Ceres got ejected. Wow, couldn't be me getting ejected out of the solar system. Poor Ceres. Couldn't be me. Could not be me. Oh, no. Ceres just got in a really eccentric orbit. That's cool. Good for Ceres. Yeah, you can see, oh, Juno is orbiting Jupiter. That's ironic, because Juno, Jupiter, same thing. So funny. What am I doing with my life? Okay. We should look at, Earth here again. We'll see that Earth is now negative 376 degrees Fahrenheit, negative 227 degrees Celsius. So now the temperature is so low that the entire atmosphere just froze. Like the atmosphere just froze. Like if we look at the atmosphere here, go to atmospheres of Earth, see how low it is. We need to go to atmospheres of Mars to see what it is. It's 12 atmospheres of Mars worth of oxygen, 0.0605 atmospheres of Mars worth of argon, 0.008682 atmospheres of Earth worth of water, and 0.182 atmospheres of Mars worth of nitrogen. Wow, it's because, I can explain this too. This is because the temperature got so cold that all the gases in the atmosphere started raining. They turned into liquid and eventually froze solid on the surface because there's no heat keeping everything stable. The atmosphere needs heat to stay stable. Also, now that, oh wait, we just got ejected here. Oh, yeah, Ceres. Yeah, I knew Ceres was gonna get ejected. But knowing Ceres is probably just gonna come back. Yeah, I feel like these have gotten ejected like 50 times and then just came back. Yeah, it did come back. Yeah, that's what I thought was gonna happen. Oh, Saturn. I feel like Saturn's probably gonna get ejected sometime. Same thing with Neptune, all the other outer planets, yeah. It's probably gonna get ejected. It's way too unstable. There's no way that it would possibly...
Like, there's no way that it would ever possibly, like, escape. You know? Like, I mean, no. That's not what I meant to say. Crap. Sometimes I'm stupid and say stuff that I didn't mean to say.
So far, everything is going to exactly how I expected it to. Like, this really makes sense. Because without such a strong gravity like the sun has, everything just goes bonkers. Nothing can hold still, because everything else is so much stronger compared to the largest planet ever discovered than it is compared to the sun. I don't even know what to call this thing. Because largest planet ever discovered is not nice to call something. It's like, it's just a long word to say. I think Saturn just keeps on inching outward, slowly but surely. Keeps on inching outward because Jupiter. Why? Because Jupiter. Of course it is. Of course it is. It's always Jupiter. Or it's always Jupiter. It will always be Jupiter. Jupiter is always the reason. And why that is? Well, Jupiter's mass. Let's look at Jupiter's mass real quick. See, one mass of Jupiter, that's sort of deceiving. One mass of Earth, 318 times the mass of the Earth. What about the mass of the Moon? 25,828 times the mass of the Moon. How many kilograms that is? 1.9 times 10 to the 27th power kilograms. Yeah, I think we all knew that was coming. Yeah. What about grams? 1.9 times 10 to the 30th power grams. What about milligrams? 1.9 times 10 to the 33rd power of milligrams. Pretty crazy. What about how many oceans of Earth does this weigh? I need to count how many zeros that is. 1, 2, 3, 4, 5, 6. 1,355,807 oceans of Earth worth of mass. What atmospheres of Earth? 3.69 times 10 to the 8th power masses of Earth's atmosphere. Wow. To put in perspective, Jupiter is huge. It's really huge. Really, really big. I think we all were expecting that. I wonder where the barycenter of Jupiter and the largest planet of... Oh, yep. Yeah. It's in between the orbit of Mercury and Venus. That would technically make the largest planet ever discovered in Jupiter a binary system, because if you didn't know, a barycenter is the center of mass between two objects. And so the total mass of this barycenter of the largest planet ever discovered in Jupiter combined 10.5 masses of Jupiter. Right here. Right there. Right there. I don't know if we can orbit something around it. Yeah, no, you can't. No. I wasn't expecting it to work. Alright. Let's look at Jupiter again. Actually, no. Let's pay more attention to Earth. Also, let's get rid of the barycenter. It plays no role in anything here. Earth? Let's see. How are you doing? Oh, negative 400 degrees Fahrenheit, which is, negative 240 degrees Celsius. Wow. Also, I doubt anybody's using Kelvin, but in Kelvin, that's 32 degrees Kelvin. Wow, that's crazy. Yeah, this is a wreck. This is an absolute freaking wreck. So how about we fix this? How about we just you know what? I'm done. I'm so done with this carnage and wreckage. I'm so done. I am so freaking done. Let's fix this in style. Here we go. Where is that? Where is it? let's fix this in style. Okay, but first I need to find the object that I use to fix things in style. Here it is. That's the entire solar system right there. Okay, and that's Ton 618, the largest black hole we've ever discovered. That's our entire solar system. That's the black hole. Boom. Just got eaten. Well, that's gonna be it for today's video. So I'll see y'all next time. And I think I am going to be posting more space-related content like this. So hope to see y'all later, and see y'all in the next one.